I literally just felt a chip. The UMC doesn't have a top enclosure. I literally just felt a chip bounce onto my.
This is 350. All your setup sheets. So that's exciting, right?
Woo. There we go, tool change. So that's, oh my God, amazing.
This is what the program looks like when it probes. So it calls the probe up, it goes in, turns the probe on, goes into safe mode, does the probe cycle for 1.5.
So these are all just the Renishaw
Just the Renishaw, yeah. So then here I put an M0, and here I tell the operator, so this is what the operator is going to see. Macro variable 188 size should be 1.5 plus minus half thou. So you can see here we're with 30 million, 300 million saw, 30 million saw.
Awesome.
Yeah. So then he can decide if he's just going to hit go or not.
So folks, we are here at Selway. Selway Tool with Tim Paul from Autodesk. We were hanging out at AV Tool this morning, and Tim did a HSM Fusion 360 meetup here last night. Made a bunch of these parts with this awesome Raptor 5-axis work holding on this what is this, a 750 SS?
750 SS, yeah.
So pretty crazy big 5-axis machine, and let's we got a ShearHog?
Yeah, we got a ShearHog, 1 1/4 ShearHog. It's cutting 800 inches a minute, 15,000 RPM, 154 thou step down, and I haven't calculated the exact step over, but I let it go up to 75% rating.
Is it a 3D adaptive strategy out of HSM?
3D adaptive, yeah, cutting the profile. So we'll see that part on the outs, in the middle. We'll ghost cut the outside there. So we're going to go to memory. Go to memory. 5%.
There's the ShearHog.
Now it's going to do a finish pass.
Oh, interesting.
I could have used a face mill, but actually the top finish is pretty good if you slow down a little bit. So now is the exciting part.
Oh, here we go. I literally just felt a chip. The UMC doesn't have a top enclosure. I literally just felt a chip bounce onto my head. That's amazing.
Don't look up.
Yeah, don't look up.
Probably not the best part for the ShearHog, but it's still a pretty good part for it.
Yeah. The idea here obviously is demonstrating the machine, the tools, the tool pass. Obviously you wouldn't start with stock that big. Oh my God, amazing.
I'm going to watch it. It's that facing pass.
So just air cutting a part that was left over from last night.
Yeah.
Spindle is so quiet.
Yeah, that's even that is 15,000 RPM.
Yeah,
right there.
it's not. It's all.
So this is with G187P command. Lets it move around for roughing or finishing.
Subject to a tolerance?
Yeah, so last night I had it on P1 and it was moving a lot faster.
Interesting.
I only had a 10 thou stock to leave, so what was happening is because it does affect the tolerance, because it was kind of hitting the corners. So I went to P2. I probably should have just left more material.
Yeah, 20 thou stock to leave. Oh my gosh, amazing.
So it's a pretty exciting indexing moves later.
Yeah?
Spindle gets probably 100 thou away from one of those parts, or all of the parts. When it's cutting the side hole on the center part.
Oh really?
It's exciting, yeah. But I model up the tool holder as the whole spindle.
So a quasi machine sim.
Yeah. Gives me the same result.
It's a really big machine. Or tall, I guess.
Big machine.
Yeah. 40 tool holder. Same one we got. Although ours does tool changes slower. But the M3 does.
Yeah.
Got it.
It's
this
50%.
one's pretty quick.
So the next tool change,
Oh, so here's going to rotate.
Next tool change, I'll show you how fast it is.
The through spindle on the tool holder, not through the tool, but just through the tool holder.
I didn't get the right tool.
No, that's okay. That's still really
cool. So it
cool.
should be through the tool. This is a Swift Carb ramp mill.
Okay.
It's going to ramp at 12-degree helix angle.
Wow, that's really steep.
175 inches a minute.
Holy cow.
Yeah.
Because the default is 2 degrees, I think, and I usually bump it up to 5. You're doing 12.
Yeah, 12. So the gash angle, we'll look at the tool later, but the gash angle is what determines what you can do. So, ready? This is 350,
oh my God.
360 inches a minute. It almost looks like it's drilling.
Oh my God, it's done.
This is pretty exciting right here. Watch how close the spindle gets to this part from over here.
On the back side.
Yeah. See that?
Yeah. Holy cow. Oh. You got it modeled up. You were good.
I modeled up. It's good.
And so Raptor makes that whole all the black stuff there. Yeah.
The riser and the those are dash 002 dovetails. So the coolant, you can see, is just coming out of the collet because I didn't have the tool. You see how close the head's getting to the platter.
Oh my God! It just blew through that sidewall with that hole.
Yeah. It's around pretty good. Through spindle coolant helps with the chips a lot. And that's only 300 psi.
Yeah. Got it. It's funny because it seems to be like either 300 or 1,000, and we got 300, and I'm still like, our shop air is 100. That's 3 times in a liquid that's not compressible. That's a lot of pressure. Oh my God.
Where you really need the higher pressures with the smaller tools.
Okay.
Because you just don't get any volume out of the small through spindle holes.
Interesting. Yeah, code looks familiar. That's so cool how that rotates.
So if this spindle takes a second to purge the system before it changes, this is your speed right there.
Oh, that's fine. Yeah. What are we on now?
So
look at that.
Some finishing.
So
it's gonna make a little. I'm cutting too much material right there, but I didn't have time to change it last night.
You didn't leave any stick out.
It's got a 50 thou clearance there. It's all modeled in software, so it's fine. I think it was 50 thou. It's a little bit less here. It's like 25 in it. Right, yeah.
I mean, you're still talking 6 sheets of paper.
Yeah. You got to learn how to trust your system, whatever your system is. And that's.
What sort of tool holder is that?
So that's a SK16 Merit tool.
Okay.
I checked the run out on this one to be well under a tenth.
Wow. So compared to ER, it's just a steeper.
Yeah, I think it's an 8-degree collet. ER is 16,
I think.
Yeah.
So you're going to get more
concentricity. More dripping power. Concentricity is, better as well. I've never seen that out of an ER32 without rotating the collet and checking it, rotating the collet. So. So again, you can see there's some pretty tight clearance. And this tool has the 2-spindle coolant coming through the tool itself.
Right.
So this part is 2 operations instead of, would that be 1, 2, 3, 4. It's going to be 1 on the UMC and then 1 on the VF2 over there.
What are we doing on the VF2 again?
We're going to do a counterbore on the backside.
Yeah.
But we're going to face the material off, probe the bore.
Exactly.
So it's going to be super concentric.
And you're using the HSM probing routine to do that midstream.
Yep.
Awesome.
Yeah. So new on the next gen control, you can turn the auxiliary coolant off without going through a whole routine.
Okay.
You gotta stop the spindle, stop the auxiliary coolant. That's new for the next gen control. I don't remember the hand, the secret, recipe before, but
you can stop you just did a feed hold in the middle of the program?
I just did a feed hold,
yeah.
And then I stopped the spindle, turned the auxiliary coolant off, and then restarted it. You didn't have to restart the spindle, you just hit cycle start, and it's smart enough to know
yep.
the spindle should be moving.
And what do you mean by auxiliary coolant?
So that's the 3-spindle coolant.
I see. Oh, because the other one is your traditional...
And just flood, and that's easy to turn on and off.
Yeah, yeah. You're not scratching the glass when you do that?
This is the new glass. It doesn't scratch very easy.
That's great.
It's
that was one of my big questions.
Yeah, the old plastic did.
Mm-hmm.
The new glass is pretty good. I think it's actually ballistic glass or something like that.
So 50 thou clearance between the nose of the collet nut and the top of the part, but when we go into the ID, we're looking at 25 thou, which is, clearance.
Yeah, that's plenty if you trust it. So it really comes to how well you follow your setup sheets.
Mm-hmm.
So that's exciting, right?
Woo! That's really cool. So did you do this as a pattern in the cam?
Yeah. So I only programmed the center part.
Wow.
And then I did a component pattern.
Yeah, that's awesome.
All 4 parts are programmed off of the one.
But with a couple of clicks, you could switch between tool change mode, sort of in part mode.
Yeah.
Right.
I could have had it made each part individually. Mm-hmm. With this, I prioritized it to sort by tool, or priority with the tool. And it still respects, what has to come in front of what. So.
And a dumb question, but obviously the knuckle only turns that way. It doesn't need to go around because to get to the same axis, it could go this way and rotate the platter.
Exactly.
Right.
It has, I think, 10 degrees of rotation the other way.
Because you've got the probe over there in the corner anyway.
Yeah. So then right here, it's deburring it with a bullnose.
Oh,
so
awesome.
Just because I didn't want to get another tool for the demo. That was long enough to clear all that.
Mm-hmm. Now, when you just do stuff like this, are you still torquing down the SK to a torque, or just tightening it by hand?
That's a great question. So I've been looking for a torque wrench that'll torque the SK 16. I can't find one.
Interesting.
So if you find one, let me know.
Yeah, right.
But right now, I just German torque bed of good and tight.
Yeah. Yeah.
I've had a couple pull out on me from just roughing super hard.
Huh.
But really, 1.5 inch long, 1/2 inch tools, it really fast. So I still use Uber Chuck for most of our roughing. The roughing you saw earlier.
I don't know what that is.
An Uber Chuck, it's a real high torque holder. We'll have to pull one out and show you. I've never had a pull out. I would say an Uber Chuck has at least as much gripping force as a shrink bit.
Wow, interesting. So that's a brand?
Yeah, and it's got a worm gear on the inside that pulls the collet in.
Whoa, cool.
Actually,
This will never get old to watch, by the way. This is just amazing. God, look at the clearance. Do you see? We missed it. But right there between the spindle. There we go, tool change. So that's, oh my God, amazing. So we got a deep burr or chamfer tool.
Yeah, so now we're chamfering the top.
What we got here?
So here's the Uber chuck. This is one of the long ones.
Whoa.
But what you have is this tool goes in here, and it draws a drawbar down with worm gears and some stuff in there.
Oh, interesting. Look at this, like almost like an Acme thread.
Yeah. So that threads into the drawbar.
Wow.
And you can see the angle on that collet is huge amount. What it is. But it pulls it very tight, super concentric.
You're having a hard time with that word today.
Yeah. So you thread that in there. It comes with, or you buy a torque wrench. And you tighten it up to a torque value, and it pulls it in there.
Right. So it's just a 1/4-inch tool. I mean, just any end mill.
This one's a 1/4-inch tool. Yeah. The one we have in there is a 1/2 inch, and it's also a shorter gauge length.
Okay, and so and this is new to me. Gauge length is what? The center line of the, or?
Yeah, it's basically the height from the spindle down.
Okay.
Is your gauge length.
Got it.
And there's actually a point on the taper. It's not, a lot of people think it's the flange. But, so here's, we're going to probe it.
Cool. So this is mid-cycle probing routine.
So we're just going to inspect the bore.
And is this going to put out that variable we were looking at?
Put out the variable we were looking at before in 188. So it's going to come down, measure that bore. Probably should have had like a
wash
air
cycle.
blowout cycle or something, but. Okay, so if you look here, we have the M0.
Yep.
And then the operator's told the size should be 1.5 plus minus 1/2 thou. So we look down here, we're 3/10.
That's awesome. It's awesome. Not even 2.5 tenths.
Yeah, not even 2.5. Yeah, so you just hit cycle start.
And it resumes.
Finish, and it's all ready for the next.
And so prior to this, you would have to write that by hand or load a program and then come back, right?
I had a good career of adding macros and all the probing is in process or shifting and that kind of thing. So now we're adding it to our software. I think a lot more people will be able to utilize it.
And this is not in Fusion today, but soon.
I think within the month.
Yeah. It's not like a long development time.
No. So it's in Inventor right now. It's coming in Fusion and HSMWorks.
Awesome.
Now we'll show you taking these parts and putting them in the VF2 SS, right?
Cool.
So let's see if we have anything down there already. Okay.
All right, so we got VF2 SS. We got the part. We just pulled off the 750, and we're just throwing in a set of soft jaws here, right?
Yeah, I'm just gonna put it in the soft jaws. So what we have here is
interesting. Sorry, go ahead.
Yeah, so I have 2 stops machined in there. This is gonna be where you're gonna probe. You could also probe it anywhere you want, but in theory, we could leave the G54 here, and then do a bunch of operations,
right,
and then just shift it around based on the the dimensions that you machined before.
Sure.
So you don't have to. I know people that would spend a ton of energy, making this plus minus 1/2 thou because the concentricity to this pocket here is super important.
Got it.
And they're picking it up off of here, where instead. We can just face it off. Now we'll expose this hole.
And then you can probe it.
Yeah.
And for you guys that don't know, so this is a really common thing to use dovetails for 5-axis work holding. And so you can actually buy this stuff pre-made blanks with the dovetail on them.
Yeah, TCI.
But now we got to get rid of it.
Yeah. Or it's easy to machine machine the blanks as well. So.
Oh, 2 at a time.
Yeah, we're just going to do 2 at a time. This part doesn't matter, how we put them in.
I can't do it.
Okay, so this is a program CJ wrote, so I'm just kind of checking to make sure everything's good. We'll run it a little slow at first. I'm going to pull it off for now. So if you don't know about position to go, being a new HAAS guy, on the new controller you go to position, and distance to go is always your friend.
Yeah.
So it still has 400 thou to go. Looks like it's in the right place.
Right, right. It's the sanity check.
Yeah,
the smell
it's the
test.
sanity check, exactly. So,
what RPM?
This is 5,200, 80 inches a minute. I've cut with this Mitsubishi cutter. I've cut at 500 inches a minute at 15,000 RPM, but it's nice and conservative. So what you're going to see in a second is you're going to see it's going to sound funny.
Right. Look at that.
Yeah, but it's basically got a piece
flashing.
of paper right there.
Right. Yep.
But now you're exposing what you need to make the countable on the back concentric with that through hole.
Right. And it's funny because as a really small job shop, I am never gonna. I'm almost always gonna buy stock, a little oversized, flip it and deck it. And so often we do this: we deck it and then we measure. Yeah. You just don't have any geometry prior to.
Yep. So now, so you can see how slow that was. That means whoever set this up had the probe set up as a heavy tool, so it did a slower tool change. Now it's gonna measure that bore.
And all of that bore is obviously made from the 750.
Yep, that bore is made by the 750. So now the next feature. Now, if that center was off of where it basically should be, it would have shifted it over the 1 or 2 thou. If I had a chip in there and the part was off a little bit, it's still plenty accurate enough to face it. But now we're just deburring it.
So that's what I still didn't understand. So we had a center spot in the back of our soft jaw that was G54. Yeah. When you just did a probing routine on that bore, are you changing G54 to a completely new position?
No, it's shifting it because in the software it knows where it should be.
Really? So G54 is now
same location, but it just moved 2 thou. Or 1 thou or
sure. Cool.
So it's doing it again because you don't know if you got a chip in there or whatever they.
So could we have had 2 different variables and had it done the tool probing all at once and stored the left one as one, the right one as another?
You could have.
You get more complicated, but it saves you the.
Exactly. But because it didn't move it very much, you can safely load the next parts and run it again, knowing that your 54 only moved, 2 thou.
Ooh, that was
yeah. So same thing if you were deburring the outside of this part, but maybe your tolerance was plus or minus 10 and you used the plus or minus 10. If your original work coordinate was on the upper left, you could have basically a perfect chamfer here and a no chamfer on the other side. Right?
Sure.
So by locating it and then shifting it to where it's actually at, now you're going to have a perfect chamfer, even chamfer all the way around.
We say that in our little CNC training classes, that chamfers betray offsets.
Exactly.
So easy to see 3 thou in a chamfer.
Yeah. And I worked at a job that we had, 2 to 5 thou chamfers were the call out.
Wow.
So, their spec was deburr all edges, minimum 2 thou, max 5 thou.
Yeah.
So you're talking about
what mattered.
Yeah, exactly.
Sweet.
So,
dude, Tim, thanks for the demo.
Yeah, no problem.
Cool.
Thanks for having me.